All right, so this is the reason we talked about all those other things before about the normal distribution. We're going to put all of that together and actually calculate a probability question involving the normal distribution. So we're basically going to be, excuse me, taking that normal curve and identifying a position in that curve and then looking at a portion or proportion of the area or of the distribution in terms of a probability. So these are like general guideline on what I would like you to do in solving a normal distribution. Um, it's always good to start by rewriting the question as a probability notation in terms of your variable x. So that would be like having a p, you'd have your x, and then you're going to put some inequality in here somewhere, probably a number over here, or you could be in between two numbers. We'll look at that. This is important. This is like your work. You're going to draw a sketch of the picture of the distribution, mark your location, like I did up here, whatever your x is, and then you're going to shade the portion of the curve you're interested in. That's going to help you when you go to put it into your calculator. You have a couple of options. You can standardize your x, meaning you can find z if you want to. You can find your z-score, and then you're dealing with zeros, ones, twos, etc. Or you can not standardize, and I will show you in both cases how you can use your calculator and this normal CDF function to find the shaded region. And then you should always write your answer in context of the problem. So I'm prepping some of you for AP Stats with this. If you're doing AP Stats, you're going to be very particular about what you can write down in terms of this normal CDF function. You need to give enough work that they can see how you got your answer down here, and you must write it in terms of the problem or you won't get full credit. Notice this is normal CDF. We will never, ever use normal PDF. I know we used binomial PDF because that was an equal to, but in the normal distribution, we're talking about area, so we will always have an inequality, and we will never have an equal to for normal. So we will always use normal CDF, never PDF. All right, so I'm going to go through an example, and then you're going to try some. Here we go. Tiger Woods practices his swing, etc., etc., etc. We've got information that it's normal, so that allows me to use this function on my calculator. If I don't know it's normal, I can't do this, but I'm told it's normal, so I'm good. There's my mean, it's 304. That's helpful. There's my standard deviation, sigma. That's helpful. And I want to know the percent of his drives that travel at least 90 yards. So I'm interested in x is the number of yards it would travel, so my probability calculation is at least is a greater than or equal to 290. And in normal distribution, again, different than binomial, a greater than 290 and a greater than or equal to 290 are the exact same calculation, exact same answer. So that doesn't matter whether this is greater than or equal to for normal distributions. Big difference in binomial. All right, so what that means is I've got a little picture. I can quickly sketch. I've done step 1, step 2. That was not actually my normal curve. That was my x-axis. We got a mean of 304. So there's 304 right there. And a standard deviation of 8. So one deviation below that would be 296. And another deviation below that, I like to make that go all the way up, would be another 8, so 282. And the only reason I'm doing it to the left is I'm interested in 290 yards, which is, this is actually not correct. I don't know why I wrote 90 there. Let me fix these. My standard deviation is 8, so 304 minus 8 would be 296. And minus another 8 would be 288. So those are my values down there. Now, I'm interested in 290 or more. So 290 is like right around here. That's my 290. And if I want to know the probability of him having a swing greater than 290 or what percent of his drives are greater than 290, those are the same question. I'm interested in all of this region over here. So by marking it and shading it, I can tell my answer should be, it should be quite a few. It should be pretty big. So what I'm going to do is I'm going to convert this to a z-score, and I'm going to show you how to do this two ways. So if I convert this to a z-score, I want to be greater than or equal to, and I would be like 290, value of interest. This is linked to last class, minus the mean, 304, divided by a standard deviation of 8. And if I did this little z calculation here, I would get a negative 1.75. And so if I were marking down here, my graph, this would be 0, -1, -2. And notice how that still falls in the same location, whether it's this number of deviations below average or the actual number in relation to his distribution. So to calculate this, I am going to go to my calculator, and this part is new to you. So this is one you may want to jot some notes down or slow down and rewatch it. I'm going to go to this distribution place just like we did with binomial, but notice the normal's right at the top. You will never use number 1. If you do, you will get an answer wrong every time. So just there you go. Don't ever use it. I'm going to go to normal CDF because I'm accumulating everything from 290 up. And I'm going to show you how to do it if you have a z-score first. If you have the z-score, you will keep mean of 0 and standard deviation of 1. This is a standardized mean and standard deviation. It's also the default. So if you have a z-score, you don't change these things. And I do have a z-score, but this is also where the picture helps. Notice that it has a lower and an upper bound. Well, if you look at a normal curve, you will always have a left and a right side that you're trying to capture in between. And if you have the picture shaded, I can clearly see that my left side is right here, which was negative 1.75. And my upper, well, I'm just going till infinity. So if I'm in z-scores, remember, z-scores are your number of deviations. And so once you get to 3 deviations, you've captured almost 100% of the distribution. So my upper is infinity, but in a normal distribution that's standardized, I can use the numbers like 9, 9, 9, 9, 9. That's even way more excessive than I probably need to. Keeping in mind that about 3 deviations captures everything, this is basically infinity in a normal distribution if I'm doing it with z-score. So this is a z-score calculation. I've used my z-score as my marker. That's my left or lower. I'm going up to infinity, and if I'm got a z-score, I use 0 and 1. And that's it. I come down here and I paste that thing right there. That just tells me what my commands are. And so my answer is 0.9599. So the answer to this would be 0.9599. And if I wanted to answer it in context, I'd say there's about a 96% chance that Tiger Woods hits greater than 290 yards. There we go. All right, so I'm going to do example 2. Now I say it's more complicated is because I've got 2 different, I want to go in between 305 and 325. So this as a probability is saying what's the chance that I'm between, my drives are between 305 and 325. Now again, it doesn't matter if I put these guys under here or not in a normal distribution. You can put them there or not. This doesn't indicate that it includes them. It just says between them, so I don't need those little markers in there, but the answers wouldn't change at all. So this, again, I'm going to use the same picture because I've got it up there and handy. 305 is about right here, right? Boom, there's 305. And 325 is going to be over here somewhere. I could mark this thing off if I wanted to be a little bit more accurate. I believe 8 was my standard deviation, so that'd be 312, 320. And so I'm interested in being between 305, which is an odd placement in here, and 325. And so I'm interested in this purple shaded region now. So notice how, again, I've got a sketch. I kind of did the lazy route, and I used the sketch I already had. Probably on a test, I wouldn't recommend that. I'd do a new sketch. But I'm interested in this purple region. It should be less than half because I'm to the right of the mean, and I'm not all the way over here. And I'm going to show you how to use your calculator again a little bit differently this time. So now when I go to second bars and choose normal CDF, I'm going to use the values that are here. I'm not going to bother getting z-scores this time. My left bound is 305, which is right here, so I can just type in 305. And my upper bound is stopping at 325. So I type in 325. So I'm telling it the actual values in my distribution. If I do that, then the mean isn't 0 and 1 anymore because these are not z-scores, they're not standardized. So I would have to put in the mean of the distribution, which was 304, and the standard deviation of the distribution, which was 8. So I have to put in the actual values of the mean and standard deviation of the distribution. Keep in mind that if this did go up to the right forever, instead of stopping at 325, I would have to use, that's why the default on this is often that 1e to the negative 99 or negative 1e to the 99. This really needs to be an excessively large number. So depending on what these values are, you might have to put a whole bunch of 9s in here or do your 1e to the 99, which is 1 with 99 zeros after it. But in this case, I've got myself captured in between the two. I come down here and I paste, and again, it just tells me what I'm putting in there. And there it is. It's just a little bit under half. The answer makes sense, 4459. So this would be 0.4459, and I'd say about 45% of Tiger Woods drives are between 305 and 325 yards. All right, the last example before you try these. What distance would the ball have to travel to be at the 80th percentile? So notice that I don't know the distance. The x is a question mark. I don't actually know. And what I know now is the percentage or the area. I've given you the portion of the curve that I'm interested in. So I don't have an inequality to write. I do want to sketch the picture though. So the 80th percentile is indicating that 80% of the drives are at or below that marker. So that's important. So again, if that's 50%, I don't really know exactly where it is, but this is the shaded area that I've given you. I've given you that 0.80. And what I don't know is what drive length gets me at the 80th percentile. So I have to do this backwards. This is a backwards problem. Up here I gave you x and you found this 80. Now I give you 80 and you have to find x. So when you're given the percentage or the area or the proportion, you have to go backwards, which is in our calculator called invert norm. And again, I will show you kind of the shortcut for this because it's much nicer. It's in the same location. I go second bars. Notice it's the third one down. This is going to do the normal distribution backwards. It asks for the area. My calculator lets me tell what direction. Some of yours won't, and so you need to be aware that yours are defaulted to the left, and so you might have to switch this area depending on that. But I have 80% of the area. The mean is still 304, I believe, and his standard deviation was 8. So you could do this standardized, or you can do it with the actual values. My 80 is to the left, and so I hit enter, or I have to paste again, and it gives me 310.73. So this answer would be 310.73 yards. And I had to use invert norm, and I put in the 0.80, and then I put in the mean and the standard deviation. There you go. Oh, and I actually put, and that gave me the actual x value for that. All right, you are going to try a couple of these. Your distribution is cholesterol levels. You got your mean and your standard deviation. So pause the video and try number 1. Here's your graph. There's your probability. If you did a z-score, you would have got 2.3 repeating, and you need to put in all those decimals or you'll get a slightly different answer. If you use the other technique where you just put in 240, your upper bound would be 9999999, and you would get 0.0098. All right, you are going to now try number 2. Pause video, give it a try. Okay, so if you did it with just the values versus z-scores, again, I put the 1, 2, 3 in red because that would be your number of deviations, so you'd still see be at 1 and about 2.33 here, and your answer should have been 0.1488 or 14.9%. All right, now you're going to figure out the cholesterol level that marks the first quartile in this distribution. So pause it and give this one a try. Pause it. This one I've given you first quartile. First quartile is the 25th percentile. That's a marker on the left. And so I have to invert norm, that 0.25, and my answer should have been 149.8. And that is I believe, all our examples for today. Good luck trying these. And as always, let me know if you have questions. Bye.